Welcome to Unity. Unity is an incredible software development platform that allows you to create anything you can imagine. Unity is used in many industries, from games, to film and animation, to artificial intelligence, to most recently, the automotive industry. Whether you want to build an application for entertainment or to solve real-world problems, you can use Unity to bring your project ideas to life. Unity allows you to build your project once and deploy it anywhere. Unity supports over 25 different hardware platforms, including desktop, mobile, VR, and consoles, with new platforms being added when they are available. To build projects in Unity, you work inside the Unity editor, bringing in 2D and 3D art assets and creating C# scripts that can be applied to game objects to give them behaviors. Unity 2017 ships with MondoDevelop and Visual Studio. You'll learn about these two programs later. With Unity, you're getting an entire ecosystem. Unity Connect allows you to network with other developers and discover inspiration by viewing what thousands of people, just like you, are currently working on. Then there's Unity Teams, a group of services that help streamline the development process, including compiling applications in the cloud and managing team collaboration. Unity also has the Unity Asset Store, where you can find thousands of free and paid assets to help prototype your projects and bring them to a commercial-ready state. Unity provides a handful of great services like performance reporting, analytics, multiplayer, in-app purchases, and Unity ads. Throughout this course, you will be developing the Zombie Toys game. All of the game assets will be provided for you, and you'll be guided by experts to discover the many features of Unity, such as game programming, lighting your environment, working with the particle system, and more. The videos in this course were originally recorded using Unity version 5.4. We have updated the current version so that you can follow along with Unity version 2017.4. I will be popping into various sections to highlight some critical changes and improvements to the platform, and to ensure that you're able to complete the course. Are you ready to step into the exciting world of game development? We'll see you in the next video.
Worldwide game status as of 2015 is as follows. 32% of the market is in North America. 4% and growing is in Latin America. Europe, Middle East, and Africa comprise 28% of the market, and 36% is Asia and the Pacific, a growth area. Some growth factors in gaming include free-to-play games, promoting an easy adoption to engage players. With no cost to play the game, developers can monetize through in-app purchases and ads. Mobile games continue to be a growth area as well. They're a low-cost technology with widespread networks. When we look at the distribution of revenue by game type, mobile continues to be a leader with nearly 30% of overall gaming revenue. This is followed closely by retail and then free-to-play, massively multiplayer online games. Rounding out this, we have social, PC download content, and digital consoles. Consoles and pay-to-play MMOs make up a small market share, and we're seeing continued growth in VR and esports. A number of market trends are at play as well, increasing the global games market. There's a number of new platforms, with new ones being deployed every day, and supported by Unity, that allow developers to pick and choose their market areas. New markets are emerging in virtual reality, augmented reality, and esports, and again with mobile gaming continuing to expand. The proliferation of mobile screens, the growth of the types of screens, and the sizes of screens allow for more development possibilities, as well as more opportunities for people to play and purchase in the game. We'll continue to see an increase in free games, as people are used to trying more and more games, so monetization changes from buying a game to a mix of buying and/or in-game purchases. Lastly, we're seeing business model balancing, where games must balance keeping the free users engaged, often the majority of game players, and spending by those who are willing to spend. The other clear trend that's emerged is that games are global and diverse in not only whom they're made for and how they're made, but how they're distributed and on what platform. Markets regularly cross national, language, and cultural boundaries. Games are services. And what this means is that any publisher needs a varying monetization strategy, which raises the stakes for a game to engage the users. And also they need to develop different means of reaching and motivating those users to purchase. And this may vary by region and by market. There's no single dominant force in game development. Companies and even individuals can publish games for almost any market they'd like. Online capabilities and mobile market growth has led to creating a truly global marketplace and workforce. Making games is a business, and any business needs a viable business model and way to generate revenue in order to survive. What we'll see is that there are many different ways to monetize a game. I'm here on the Apple App Store, and we can see there's different models of monetizing games. We may buy a game outright, and then possibly buy or be awarded, depending on the price, different upgrades. We also see a freemium model, where games are free to play, and then upgraded content is available, or a player may view ads between levels. We may also see in-app purchases that help to monetize the game, where a game may be free, but then the publisher allows people to buy upgrades along the course of gameplay. Here in the Google Play Store, we'll see the same kind of models. There are many games that are free, for example, and have ads to support their business or in-app purchases. Again, all of these are viable business models, whether a game is bought outright, either on physical media or downloaded, or it's free to play with upgrades possible. The Unity platform is poised to take advantage of these different monetization models. I'm here in my Unity editor and in the services window, and I'll create a Unity project ID and then have access to all the different services available. What we'll see here is that in Unity we can link ads in, either simple or rewarded ads, into our game. One of the main differences between the ad types is that rewarded ads, where a user must watch the ad all the way through in order to proceed, can't be skipped by default. Simple ads can. This way, publishers can make sure that players are watching the ads in their game and thereby receive a share of revenue from that advertiser. We'll also see in here different analytics under Unity Analytics, and this will let publishers understand how players play the game and let the publisher fine-tune the gameplay as they learn about player behaviors. We can also enable in-app purchasing. And again, this allows players during the course of the game to upgrade things like characters, for example, or buy new characters or upgrade attacks, further enhancing their game experience and letting the player feel as if they're customizing what they're doing and how they play the game. All of these different models contribute to a monetization strategy, making sure that the publisher has enough funding to continue in the development of this game and new ones. In this video, we'll look at some common game platforms, game genres, and game mechanics, and their impact on game design. I'm here on madewithunity.com, and I'll look in the search field, clicking in search, and we can see the different platforms we can author to. Additionally, we can see different categories of games. Often, games will fall into multiple categories and may be authored for multiple platforms. The platform choice may dictate the control of the game and how that game is played. It's important to consider the platform the game will be released on and the category or genre of the game, as well as the demographics of the players playing it before designing the game. Often these choices are dictated by the publisher. These are planned well in advance based on a particular intellectual property. There are many different platforms that Unity can publish to, including desktop, console, mobile, VR, TV, and web. And each of these have different platforms available from different manufacturers, such as iOS and Android or HTC Vive. Once the platform is chosen, this can dictate the kind of game, as different platforms may work better for some games than others. Looking at the categories, we can see there's action, platformer, sports, adventure, graphics, shooters, strategy, arcade, simulation, survival, and more. And each of these has different mechanics that support that game type. I've searched in platformer games for Ori and the Blind Forest, an action-adventure platformer game released on Steam and the Xbox Store. Ori and the Blind Forest is a third-person platformer action-adventure. What this means is that the player will go on an adventure through the game environments toward a particular goal. Additionally, a platformer means that this game is played on platforms, that the player views the main character and has to navigate between a series of platforms along the course of the game. Ori and the Blind Forest is also a third-person game. What a third-person game means is that the player views the main character from a third-person view. The first is the main character, the second being the non-player characters, and then the player is the third person in that environment. Often in a third-person game, we'll see a great deal more of the environment than we would from a first-person game, where the player is viewing the game from the perspective of the main character. Firewatch by Camposanto is a first-person adventure game. It's available on Linux, PlayStation 4, Mac, and Windows. In this game, you play the main character and see things from his view. When we look at an image from the game, we can see a marked difference between a first and a third-person game. A first-person game, then, is played from a very close viewpoint. It's an intimate view of the game and its environs, as different from a third-person, which is often shown quite removed from that main character. A third-person game may alternately be seen from over the shoulder of the main character, a more intimate view but still seeing most of the main character on screen during gameplay. Subway Surfers is another example of a third-person game, an endless runner where the main character is running along procedurally generated tracks in procedurally generated scenery. In Subway Surfer, there is no stopping in the game. You're simply running forward, either faster or slower, and jumping over procedurally placed train cars and other obstacles, picking up power-ups along the way. As we can see with Subway Surfer, the platform influences the controls available to the player, which in turn influence gameplay. Subway Surfer is a mobile game. Mobile controls often use the tap and swipe in addition to tilt mechanics available on mobile devices. Total War Battles Kingdom by Creative Assembly is an example of a strategy game. This kind of game emphasizes multitasking, resource planning, and real-time strategy, and is different from an action-adventure which relies more on the impulse and quick reactions of the player. Strategy games like this often see many hundreds of units in motion as guided by the player at one time. We can also categorize available games as hardcore or casual. Depending again on the market desired, you may end up designing your game for one or the other. What we'll often see is that console games are marketed towards the hardcore gamer, and these may feature longer missions and intense quests, whereas a casual game is meant to be picked up and put down in short bursts as the player has available time throughout the day. Casual games often feature simple mechanics such as arcade-style games, card games, or board games. What we'll also see is that the available resources of particular platforms a game is intended for drive the look of the game and the optimization needs when designing that game for that platform. Console games use specialized hardware optimized for the platform, and as such are very powerful and boast high-fidelity graphics. In contrast, in many mobile games, where battery life and processor power is at a premium, optimizing polygon counts and the size of textures used dictates the look of the game and also the available number of things on the screen at any one time. The platform the game will be published on, and the category of the game, the genre, plus the demographics of who the game is designed for, dictate the mechanics in the game and how it will look and play. The platform also dictates the controls found in the game and the user interface design. All of these things need to be decided before the game production begins, so that the game design document and technical design document can be crafted to support the desired platform, game type, and game mechanics. In this video, we'll take a look at the video game production pipeline. We'll start out in a game with pre-production, where we'll generate the story for the game, looking at possibly an existing intellectual property or creating a new one. At this point, we'll also create the story and the concept art, getting a general idea of each of the game characters and environments. Concept art and story are part of the game design document and technical design document, both of which we'll review in later videos. These are the working blueprints for the game and contain all the essential data on game mechanics, gameplay, character designs, levels, environments, concept art, scoring, and so forth. It's important to get these pieces nailed down before the production begins. Once pre-production is complete, the game goes into production. In production, we'll implement assets and create gameplay. creating 3D models, for example, building environments and animating characters, bringing them into our game engine, and bringing the game to life. We'll build this game for its first release. Once a game has been released, we'll go into maintenance. Maintenance involves fixing bugs that come up and releasing patches. These are incremental functionality improvements, small improvements to the game that make it function better or fix small issues. Most games have upgrades planned into their production cycle. An upgrade involves building and releasing new content, and this can range widely depending on the nature of the game. Usually these are major additions and modifications, such as new levels, for example, or seasonal content. We might see new characters debut for a game, or new environments attached to an existing level. There might be upgrades in powers, for example, or prizes available. Seasonal content might involve new skins or new looks for the game depending on a particular holiday, for example, or a season, such as a summer release featuring a beach level. It really varies depending on the nature of the game and the platform. But upgrades provide the publisher an opportunity to reinvigorate the enthusiasm of the player base for the game. In this video, we'll take a look at game studio roles and responsibilities, looking at various jobs within a game studio, and the responsibilities and contributions of each person. The art director ensures the overall look and feel of the game is consistent, and verifies that all the game assets adhere to the concept art and intellectual property specifications. The art director is responsible for the overall coherency of the game, making sure that everything fits and feels like it's in one world. The concept artist generates the initial ideas of characters and environments for the game, and really defines the look and feel of the game elements. This role may vary widely. In a larger studio, there may be dedicated concept artists who produce concept art for one or more games. In a smaller studio, the concept artist role may be taken on by other people. For example, an environment lead may be an environment concept artist, generating the initial concepts and then guiding the environment team to build that environment. Similarly, a character artist may take on character concept roles, generating the idea of the characters and then sculpting them, bringing them to life in ZBrush or Mudbox, for example. The level designer plans and builds the environments, and may also light the level and add characters depending on studio size. Again, this role varies widely, really depending on the size of the studio, the number of people making the game. In a large studio, a level designer may simply design the static environment, ready for a game designer or technical artist to actually implement the gameplay. In a smaller studio, a level designer may implement gameplay as well as placing the actual level objects in. The level designer role tends to be both an artistic and a technical position. The level designer should be able to move freely around content authoring packages such as Autodesk 3ds Max or Maya and Adobe Photoshop, as well as a game engine, and probably perform some scripting as well, bringing those game objects to life as part of gameplay. The game designer designs and implements game mechanics and gameplay in the levels, and may do a considerable amount of scripting, bringing behaviors and animations to life. Again, this role depends on the size of the studio. In smaller studios, a level designer and game designer may be the same person. In a larger studio, a level designer may make the static level, and the game designer will bring that level to life, adding in the gameplay, the various systems, autonomous and semi-autonomous, and implementing things like spawn points, for example, for non-player characters. The technical artist is a role that's cropped up recently. The technical artist will help bring assets into the game, including animations, and this is something that's historically been difficult to do. The technical artist will also ensure that the art is optimized for the game engine. The technical artist then is the interface between the content artists making the assets and the game designers. The technical artist will work in the pipeline and help develop it and streamline it, assisting in implementing the assets that other artists create. For example, a technical artist might be responsible for taking an animated character in the rig, bringing it into the game, and making sure that those animations are split apart, made into clips in an animator, and that the various states in a state machine are set, so that the behavior of the character is all ready for additional scripting. The technical artist also may work in specialized fields. For example, working in particles, shaders, lights, or economies in game. It's a myriad role, and it really depends again on the size of the studio and the nature of the game. The environment artist constructs environment assets, including models and textures, and may create environment concept art, as said previously, depending on the studio size. In larger studios, the environment artist is simply responsible for creating the environment based on concept art that others have done. There may be further specialties in this role, such as building environment artist or terrain and foliage environment artist. Again, it depends on the nature of the game and the size of the studio. This environment artist role may also lap into the role of level designer, depending on the studio's size. We may see one person taking objects from concept through implementation, under the role of level designer encompassing the environment artist. The character artist constructs characters and props, including models and textures. The character artist also may create concept art depending on the studio size. Often a character artist will work in a digital sculpting program, such as Pixologic ZBrush, for example, or Autodesk Mudbox, in conjunction with a 3D authoring package such as Autodesk Maya or 3ds Max, for example. The character artist then will take that concept art and bring it to life in 3D if it's a 3D game, taking that model through a high-res sculpt all the way into a lower res or optimized for game model, ready to hand off to a rigger or technical artist who will actually bring in the rig and get it ready for animation. This role again varies widely. There are specialized character artists that simply make the characters, leaving others to optimize the models, reducing the poly counts for implementation in game. In smaller studios, you may see one person have ownership of an asset from concept through to implementation. Again, it depends on the nature of the game and the size of the studio. Some character artists will specialize further, working in just 2D. For example, if it's a mobile or casual game geared studio, working in 2D characters that are composed of different drawn bits created in Adobe Photoshop or Illustrator or a similar package, and brought to life and animated in the game engine. Keep in mind that these are just some of the jobs we'll see at a game studio, again depending on studio size and the type of game being made. Many studios will have programmers whose sole function is to provide the scripting support to bring the game to life, working closely with a game designer and level designer. Depending on the size of the studio, we may also see sound designers whose job is to create and possibly implement sound in the game. There also may be musicians and additional composers behind the scene who make the sounds either in contract or as part of the studio. Again, depending on the size of the studio and the nature of the game. Keep in mind that these are guidelines and that these roles vary widely from studio to studio. Large enterprises, then, may have dedicated teams that handle some of these functions, or they may have teams who have overlap in these roles. Smaller studios may simply have a few people who are responsible for everything, and this really depends on the funding available, the size of the game, and the platform. In a game studio, it's essential that all the artists, designers, and programmers involved work together as a team, and communication is a big part of that. These people need to work together coherently and professionally on a daily basis, making sure that everybody can communicate, that goals are clearly stated, and objectives are met. A large part of this is the critique. Regularly, different parts of the team will be asked to critique or evaluate another's work. This is done as a professional evaluation of art, design, or code with the intent of improving the product. Remember, this is supposed to be a professional evaluation, not a personal one. It's a way to evaluate and iterate on what's going on with that work with the goal of making it better. The Game Design Document, or GDD, is an essential blueprint for building a game. Whether the game starts out for PC, mobile, console, or virtual reality, it needs to be blueprinted out thoroughly, providing a common reference and common design point for all the different members of the game team. Our Zombie Toys game design document starts out with a table of contents. The GDD then lays out how the game should be structured, what the rules of gameplay are, and the different game mechanics. We'll see things in here like score, for example, and platform requirements. In addition, the game design document will lay out who the players are and how they behave, their different animations and different attacks. We'll also see the non-player characters or NPCs laid out and their different behaviors and so forth. Our GDD starts out with a game overview, a one-paragraph summary of the game, detailing out who the player is and the general game mechanic. It'll also list out the platform, the genre, a rating if applicable, a target demographic, and a release date. What we'll also see in here are unique selling points for marketing, for example. It's important in the game design document then to lay out how the game will be played, as these rules laid out here are what will be implemented later by gameplay designers, level designers, and other personnel on the team, making sure that the game functions as it's expected to, and that players get a rewarding and rich game experience. Our Zombie Toys game is fairly simple. We have a character selection, a gameplay, and a losing screen. We have essentially one level, which is our entire game world. However, many games are more complex than this, and so laying out the structure of levels, and possibly even ads between them and so forth, or cinematics, is important. We need to know the flow of the game, and how the player will get around, what the states for advancement are, and so on. And the GDD is where we lay those things out before we build the game. The game design document will also lay out the different controls. Depending on the platform, these may vary widely. For example, our game is going to be on a PC initially, and so we're going to see a standard mapping of W, A, S, and D keys for forward, left, right, and back. We'll also see the tab key for switching weapons, and the left mouse for fire. Rotating or looking around will be done by moving the mouse. The controls then change for mobile. We'll see two-finger controls. When the phone or other device is turned sideways, we'll see the control in the right or left bottom corners. Again, it's important to design the controls and recognize the platforms before game construction begins, as how the game is built depends on where it's going and the plans in the game design document. The game design document will lay out the environment. In this case, for Zombie Toys, we'll see that the environment is seen from a three-quarter perspective and is actually rotated 45 degrees. And this allows us to have the player not duck behind too many obstacles and be almost always in view. It'll also let the main camera be aligned with the world axis, which is important for getting the movement on the camera right and making it a bit easier to implement. Our game design document will lay out the HUD, or heads-up display, and indicate what goes on it. This will be important when we get into user interface design. Beyond stating the game rules and game mechanics and scoring, we'll see that the game design document details the player and non-player characters. We'll see, for example, concept art of that different player. Often we'll see a player in different upgrade states, for example, different costume changes, maybe with different weaponry or props. We'll see different color studies, and also detailed drawings, giving character artists, for example, a guideline of how to build that character in 3D. We'll see in here as well the different player states, and this tells animators how they need to animate that player. These states will become cycles that we'll later implement in an animator controller. We've got idle, move, and death, making sure that our character is reacting properly to what's going on in the game. The GDD will also lay out things like weapons and attacks. We'll see this often for the player and non-player characters depending on the game. This will form a blueprint for our effects artists, for example, to construct the different effects, lightning, freeze, stink, and slime, that will be used by the player. What we can see also in the description here is that beyond telling what they are and how they look, we have an effect, a cooldown, and an indication of a reticle, or targeting device. Again, it's important to lay this out so that different parts of the team can access common knowledge, this blueprint, and construct the game appropriately. Here's a character lineup showing all the different members of the Zombie Toys game universe. We've got our two different players, our allies, the dog and the sheep, and the different Zombear, Zombunny, Zombie Duck, Elephant, and Clown NPCs that will come after us. This way, we can make sure that everybody fits coherently in the world, that nobody stands out as oddly placed or not fitting in the overall feel of the game. This sheet also details out then, for each enemy, their speed, maximum health, score value, attack, damage, and time to attack. And these statistics will be vital when we implement them in our different managers, making sure that everybody functions as they need to in the game. One of the most important functions of a game design document is to lay out a naming convention and detail out each and every asset needed. Now keep in mind that there will be changes over the course of the building of the game, but the game design document should strive to show complete as many of the pieces in the game as possible, making sure that every contingency has been thought of, all the different variations on attacks, for example, so that it doesn't look like the same attack over and over, making sure that the non-player characters have enough variety if you're going to see many of them, detailing out all the different animations and variations, and listing them out in a naming convention that's easy to search so that it can be referred to later in script. The game design document, then, provides a thorough blueprint for the game, an absolutely necessary component to have before the game construction begins. This way, all the different members of the team know what to build, when to build it, and how to build it, so all the different pieces of the game are constructed, drawn, and implemented properly, making sure that the player has a rich and rewarding game experience. The technical design document is an important counterpart to the game design document, where the game design document lists out the overall game rules, game mechanics, and lays out the art and different design of the game. The technical design document details out the inner workings. The TDD, then, as it's often known, will list out things like the equipment and hardware and software needed, give an executive summary or overview of the game, and a technical summary. The TDD will also schedule out the game, listing out the development plan, milestones, updates, and maintenance. It'll talk about file formats and naming conventions, and also list out, possibly in more complex games, what the different scripts are that are needed, and how they should behave and work together. We may also find in a TDD, depending on the complexity of the game, things like physics implementation details or similar technical workings. The TDD, as we can see, lists out the different schedules for the development. For example, when are the character concepts detailed, and when are they brought to life in 3D? When does their scripting take place, and how and when are they implemented? What we'll see in here is a complete plan of how that game is supposed to be built, so that project managers can implement this development plan and manage the different teams' progress. The TDD may also detail out things like updates, for example, showing that in summer we may see a beach skin, or a dog ally may be added later. We might see a Christmas or other holiday skin showing up, again so users can download a different look to their game and implement it, feeling that the game is staying alive and vibrant. The TDD will also list out the different details that will let the team function coherently. What we'll see here are the different asset types listed and what their file format is and their naming convention. This way, in the game pipeline, different members of the team can be consistent in their naming and placement of files. Remember that it's very likely in a game to have hundreds, if not thousands, of objects between characters, scripts, environment objects, lights, and so forth. And then there are native objects in Unity, such as prefabs, for example. Having consistent naming for all of these, placement, and recognizing where in the project they sit is highly important, as it's very easy to lose an asset that took a lot of time to make. A technical design document can get quite detailed then. Keep in mind that these will vary widely depending on the scope of the game and the complexity of the game mechanics and gameplay. We might see in here, for example, notes on different behaviors of different scripts, or how to implement money and in-game economies. It really depends again on the size of the game, the scope, and the gameplay, and the rules by which the game will be won or lost. Having a good TDD in hand, again, before game construction begins is essential. This way, all the different details can be mapped out and the team can work together smoothly. In this video, I'll show how to create a new Unity project. We'll create our new Unity project, sign in with our Unity ID, and configure some defaults, getting ready to import our Zombie Toys content. First, let's launch Unity, clicking on the Unity icon down here in the dock. Alternately, if you're working in Windows and have a desktop shortcut, or your Unity install is available in the Start menu, click on that icon to get started. When the Unity editor opens, you'll be asked to sign into your Unity account using the email and password you created. I'll sign in, and this will make available all the different services that are part of the Unity ecosystem. Note you can also click Work Offline if you're not connected to the internet and still need to open your Unity editor. I'll click Sign In and Sign In to Unity. Now that I'm signed in, we can see that the Unity Project Wizard recognizes me in the top right corner as Adam. The Unity Project Wizard allows us to browse existing projects we've created or create new ones. There's also a Getting Started section with a helpful welcome video and access to other learning content. I'll create a new project by clicking on the New Project button. When you create a new Unity project, you have a choice to make it a 2D or 3D project, and also to load in standard asset packages. The first thing to do, though, when creating a project is to name it. Click on the Project Name section and name this project Zombie Toys. Additionally, if you'd like to change the location of your project to another drive, you can do that in the Location section. I'm going to leave my project here in Documents for the moment. When we start a project in Unity, we can choose a 2D or a 3D project, and this sets up different defaults for each kind of project. A 2D project starts out the editor in an orthogonal viewport, and incoming images are recognized as sprites for use in a 2D game. In a 3D project, we start out in a perspective view, and incoming images are recognized as textures for use in materials. You can also bring in asset packages, and these are standard asset packages that ship with Unity. Clicking on Asset Packages then shows us a list of possible options. We can bring in 2D, cameras, characters, cross-platform input, effects, and environment, and these are just some of the assets we can bring in. You can choose to bring in some, none, or all of them, but be aware that the more asset packages you bring in, the bigger your project file size will be. In the Zombie Toys project, we'll be creating a lot of our assets or importing them from the asset store, so for now we can leave these unchecked. I'll click Create Project, and Unity will create my blank Zombie Toys project. Unity has created our blank Zombie Toys game project and has opened the Unity editor. Because we've signed in with our Unity ID, our services are available. Later, if needed, we can create a project ID and sign into an organization, allowing us access to services such as ads and analytics. For now, though, our blank Unity project is ready, and we'll go to the Asset Store and download our content for our Zombie Toys game. In this video, we'll go to the Unity Asset Store and download our content into our Unity project for our Zombie Toys game. In the Unity editor, choose Window and Asset Store from the top menu. The Unity Asset Store allows you to download content directly into your Unity editor. There is both free content available and content you can purchase. In the Asset Store, we'll search for our Zombie Toys game project, typing in the search field at the top, Zombie Toys, and pressing Enter. In the Asset Store window, we can see that the search has found all of our Zombie Toys packages. These are all packages that correspond to the different start states for each chapter. Scroll down and choose the Chapter 1 to 3 Zombie Toys project. Click on the Zombie Toys icon, and the Asset Store will open that package. As a reminder, you should be running Unity 5.3.4 or later, as these assets are made for that release of Unity or a later one. Clicking on the Download button will download your content straight into the Unity editor. For any asset, there are images available of the asset, as well as a preview video and a list of the package contents. These are Unity packages, special files that are encoded from within the Unity editor and published to the Asset Store. We can see here in our package contents all kinds of different assets that are part of our Zombie Toys game. These range from sound to models, textures, materials, and scripts, and more. Scroll up to the top and click Download. When the license agreement pops up, click Accept to accept the license agreement for our Zombie Toys game. Unity has finished downloading the content, and now we can import it into our Unity editor. Click Import on the Importing Complete Project dialog that's popped up. When you download content from the Assets Store, Unity will open a list of all the contents of that package, and this will allow you to select some, none, or all of the items you wish to import. For now, we'll leave these all checked. You can also click All or None down at the bottom, and then selectively go through and choose Assets. Click Import down in the bottom right of this dialog, and Unity will import those assets into your Unity project. Unity has imported our assets from the Assets Store directly into the Unity project, and we can see them now in the Assets folder in the project window in the lower left corner of the interface. Now we can start building our Zombie Toys game. Remember, at any point, you can create a new Unity project if you'd like, and download a particular chapter's asset package into that Unity project from the Asset Store. Next, we'll look at collaboration and source control for working in a team on a project in Unity. Game development is a collaborative process. Games are made by teams, and those team members need to be able to collaborate and share work, and ensure that work is not accidentally overwritten, and that the right work gets integrated in the game in the editor. Most game teams, then, will use some kind of source control, and this can range from simple file sharing systems like a Google Drive or Dropbox, where all the source control is manually done, to more sophisticated, proper repositories like GitHub, Mercurial, or Perforce. In addition to using source control to allow for the versioning of work and avoiding accidental overwriting, the Unity Cloud Build service requires source control to operate. What Cloud Build does is allow a project that's on some kind of source control to be built for various platforms automatically. And this way, we can save time building and instead concentrate on our work in the editor while our builds are being readied for us. We'll take a quick look at some of the source control options out there and look at the concept of a repository and what's involved. The idea of source control and a repository comes from the development side, where programmers need to be able to work on code and integrate it into the trunk or the main, making sure that the code they're working on gets properly integrated and doesn't accidentally overwrite other code. GitHub, as an example, is one of the popular source control options, providing both personal and business options depending on the size needed. Mercurial is another option for source control, again, providing options for differentiating between files, making sure that files can be branched if needed and merged back in, and so forth. Many studios also use Perforce as an example. Again, this provides a source control repository that will integrate with Unity and allow for the versioning and securing of different objects, different assets, different code, to make sure that the right version gets integrated and that work is not accidentally overwritten. Here's an example of a project in GitHub. This is the Zombie Toys project, where we're seeing the assets, builds, and project settings. What source control will track then are contributors, who's working on a project, commits, who's uploaded or pushed things to the master, integrating them into the main. It'll keep track of branches. In this case, we're seeing the various chapters for the Zombie Toys game. And again, this allows us to version, to view a project at a certain state, and roll back or forward if needed. Most source control applications have some form of analytic capability as well, looking at the number of files contributed, for example, and who's contributing. Have they gone forward or backward? What are the releases, and so forth. All of the different source control options provide good starting tutorials if you'd like to experiment with source control. All of the source control applications shown provide tutorials for getting started. From the first ideas being created, it's important that files are placed into a repository and tracked appropriately. This way, those different assets for the game can be tracked, versioned, and backed up on source control, and cloned when necessary, and shared between members of the team. Remember also, you do need source control to use Unity Cloud Build. So if you're looking at building this game for mobile, for example, you need to sign up for source control in some way, and follow the instructions for Cloud Build on the Unity site to get that going. Remember then, no matter how small the project, get it on some kind of source control. This will give you backups and the ability to version assets, and will prepare you to work in the wider world of game development. on a collaborative team.